Dr. N. Satyashila, Assistant Professor, Department of ECE, Rohini College of Engineering and Technology, Course Code 24EC304, Course Name Electronic Devices for Industrial Applications, Unit 1 Fundamentals of Semiconductors and Diodes. The lecture topic we are going to discuss today is Intrinsic Semiconductors and Extrinsic Semiconductors. On completion, the students will able to know how the semiconductor devices are made, the types of semiconductor devices, intrinsic semiconductors and extrinsic semiconductors. Semiconductors are primarily classified into two major types, intrinsic semiconductors and extrinsic semiconductors. This classification is based on their purity. Intrinsic semiconductors. An intrinsic semiconductor is a pure form of semiconductor material such as silicon or germanium without any added impurities. In an intrinsic semiconductor, the number of electrons in the conduction band is equal to the number of holes in the valence band. Key characteristics of intrinsic semiconductor: pure material, no impurities are added, equal number of electrons and holes. The electrical conductivity arises from the thermal generation of equal number of free electrons and holes. Temperature dependent. At absolute zero, intrinsic semiconductors behave as insulators. As the temperature rises, thermal energy excites electrons from the valence band to conduction band, making the material conductive. Extrinsic semiconductor. Extrinsic semiconductors are intrinsic semiconductors that have been doped with small amount of impurities to improve their electrical conductivity. The process of doping introduces either more electrons or more holes into the semiconductor, thereby altering its conductive property. Types of extrinsic semiconductors: N-type semiconductor, P-type semiconductor. N-type semiconductor. In an N-type semiconductor, an impurity is added that provides extra electrons, which become the majority charge carriers. The N stands for negative because electrons are the majority carriers. P-type semiconductor. In a P-type semiconductor, the impurity created extra holes. The P stands for positive because holes which acts like positive charge carriers are the majority carriers. N-type versus P-type semiconductor. Property: doping element. N-type semiconductor, donor, example phosphorus. P-type semiconductor are acceptor, example boron. Majority carrier. In N-type semiconductor, the majority carriers are electrons. In P-type semiconductor, the majority carrier are holes. Minority carrier in N-type semiconductor is holes, and minority carrier in P-type semiconductor is electrons. Conductivity. In N-type semiconductor, the conductivity is high due to free electrons. In P-type semiconductor, the conductivity is high due to available holes. N-type semiconductor, doping with donor atoms. A donor atom such as phosphorus is added to the material. These atoms have more valence electrons than the semiconductor, leading to extra free electrons that increases conductivity. Majority carrier is electrons, minority carrier is holes. P-type semiconductor, doped with acceptor atoms. An acceptor atom such as boron is added, which has fewer valence electrons than the semiconductor. This creates holes in the material, allowing for enhanced electric conductivity. Majority carrier holes, minority carrier electrons. The questions frequently asked are: define intrinsic semiconductor and extrinsic semiconductor. What is the difference between intrinsic semiconductor and extrinsic semiconductor? Thank you. Thank you.